Today we're going to look at the third and final way of solving a system. So today we're going to solve systems of equations by elimination. We've talked about how to solve them by graphing. We've also talked about how to solve them by substitution. So now elimination is this third and final way. So let's talk about the steps on how we would do elimination. So step number one, we want to make sure that we line up like terms from each equation if it's necessary. And so what I mean by like terms is I mean that we are going to want the x's from both equations like one on top of the other. We want the y's from both equations in the same spot, one on top of the other. We want the equal signs, one on top of the other. We want then what it's equal to, one on top of the other. So that's our first step. Our second step, we want one set of variables to be opposite. So what I mean by opposite is if I have a negative 2x on the top equation, then that means I want a positive 2x on the bottom equation. So we want one set of variables to be opposite. So we multiply an entire equation to create that if it's needed. Sometimes we might see that it's already there for us. Sometimes we might not. Today, we are going to just be practicing when we do have opposites already given to us. But then tomorrow, we'll talk about when maybe we don't start off with opposites. Our third step then is we are going to add the equations. So by adding the equations, one variable should eliminate. And so when I say eliminate, we mean that it should disappear completely. Once one of the variables has eliminated, now we're just left with one of the two. So if like the x's go away, then we only have y's. So our fourth step, solve for the variable. Since step number 4 means that we find one of the variables, but the equations start off with 2, our fifth and final step then is we are going to substitute the answer from step number 4 into any equation to find the other variable. All right, so once again, maybe the step number 4 we solved and we got x. Well, then step number 5, we need to go back and we need to solve for y because we don't want to forget, just like all these other times, our final answer is an ordered pair. Okay, so if we have an x, we'll have a y, we need an ordered pair. Okay, so once we have these 5 steps, now let's go ahead and start looking at a couple of example problems. So the directions say to solve the system by elimination and then check your solution. So if we look, notice that we have the x's one on top of the other. We have the y's one on top of the other. We have the equal signs one on top of the other. And then we have what it is equal to on top of the other. So step number 1, which says line up like terms if necessary, Well, we don't have to do anything. All the like terms are already lined up. So step number 1's already done for us. Step number 2, we want to find one set of variables to be opposite. So if I'm looking at the x's, I see a 3x and I see a 6x. 3 and 6 are not opposite. So now I move over to the y's. I see a positive 7y, and notice that I see a negative 7y. So right off the bat, I have my opposites. So step number 2, we found our opposites. So that means that we don't have to multiply anything to create that because we already have it. So that means we get to move on to step number 3. We're going to add the equations because then one of our variables should disappear. So if we add our two equations, that means that if I'm adding them together, 3x plus 6x. So I'm adding the x's. Well, 3 and 6 tell me that there are 9 x's. Because the 7 and the negative 7 are opposites, well, 7 plus negative 7, that's 0. So I'm not going to actually cross it off, but those disappear completely. You can't have 0 y's, so I don't even have to write it. I then just put equals, and now I'm going to add the numbers over here on the right. 16 plus 11 is going to give us 27. So now we want to solve for x. That means that I'm going to divide to get rid of the 9. So if I do it to the left, I do it to the right. And so 27 divided by 9 is 3. So x equals 3. So that was step number 4. We solved for the variable. But we're not done. We solved for x. There's x's and there's y's. So now we have to go back and substitute this x into either one of those original equations up here and solve for the y. So it really doesn't matter which one. I always like to see, okay, if I have x and I want to solve for y, I usually go back to the equation where the y is positive. So in this case, I'd probably go back up to the top equation. So we're going to have 3 times, not x anymore, we know that x is 3, plus 7 times y, and that equals 16. So now we have an equation where we can start solving for y. Well, 3 times 3 is 9. We'll still have plus 7y equals 16. Now I want to start solving. So I have a 9 and a 7 on the same side as y. I want to move numbers that are not connected. So positive 9, the opposite would be a negative. I'm going to subtract that. That gets rid of that. We're still left with a 7y on the left. 16 minus 9 is going to give me 7. I'm going to divide both sides by then 7. And so 7 divided by 7 is 1. Remember, our solution, our answer, in this case, is an ordered pair where we want x first, which we just found to be 3, and y second to be 1. But now before I say, okay, I'm done, the direction said check your solution. So that means that now that I have this ordered pair, I'm going to go back to the two original equations and I'm going to substitute in both those numbers. So on the top, we'll have 3 times 3 plus 7 times 1, and we want to make sure that that really does equal 16. 3 times 3 is 9. 7 times 1 is 7. 7 and 9, when you add those, it checks out. It gets you 16. So the top equation works. So now I'm going to do the bottom equation. We'll have 6 times x, but we know x is hopefully 3, minus 7 times y, which we think it's 1, and we want to make that side equal 11. So I'm going to multiply 6 times 3, gets you 18, minus 7 times 1 is 7. 18 minus 7, that does get us 11. So both of those checked out, so that indicates that yes, I absolutely know that this ordered pair of 3, 1 is my solution. Let's take a look at another example. Okay, first step, we want to make sure that all of our like terms are lined up. So notice that we've got an x on top of another x. We've got a y on top of another y. The equals are lined up. And then those numbers are lined up. So the first step checks out. All our like terms are already lined up. Second step, we look for opposites. Notice that the x, I've got a negative 4, and then on the bottom, I've got a positive 4. So I have opposites already, which means we don't have to worry about finishing the rest of step 2. We don't have to multiply anything. We have our opposites. That means we get to move on to step number 3. Now we can add our equations. So negative 4x plus 4x, that whole point is that that's going to turn to 0. That disappears. So I'm just going to move on to the y's. Don't lose the fact that that 6 is negative. So negative 6 plus 8, when I add those together, I'll have 2y. That equals, now I'm going to add 6 plus 0, so that's 6. I can now solve for y. I'm going to divide both sides by 2. I get y to be 3. So we actually just completed step number 4 of that 5-step process. Our last step in step number 5 is to now, if we solved for y, we have to go back and solve for x. So we can go back to either one of those two equations. Like I said, it doesn't matter which one, but because I want to solve for x, I notice that x is positive on the bottom, so I'm going to just go to that one. So we're going to have 4x plus 8 times, and now I get to substitute in the value for y, so that's 3. That equals 0. Let's solve for x. So we've got two numbers that we can multiply. 8 times 3 is 24. Two numbers on the same side as x. We move the number that is not connected first. So 24 was positive, so the opposite of that would be to subtract. 0 minus 24 will give us a negative 24. Last step to get the x by itself is to divide by 4. Negative 24 divided by 4 will give us negative 6. So we write our solution. We've got an ordered pair here. Remember, x goes first, so it'd be negative 6, and then our y. But before I circle that, I'm going to go back and double check that I get two true statements. So I want to double check that my algebra was correct. So on the top, we have negative 4 times x, which we think it's negative 6, minus 6 times our y, which we think it's 3, and we're hoping that it simplifies and gets us 6. So when I multiply negative times the negative, that is going to turn to a positive 24. Bring down the subtraction sign. 6 times 3 is going to give us 18. 24 minus 18, that does check out. That gets us 6. So now I'm going to the bottom equation. We'll have 4 times our x, which we once again think it's negative 6, plus 8 times y, which we think is 3, and we want that to simplify to 0. Well, 4 times negative 6 is negative 24, plus 8 times 3 is 24. Negative 24 plus 24, that will get us 0. So we checked, and this does work out. This is our solution.